All right, you guys, this is Unit 5 notes number 9, area between curves. Go ahead and write down the FLT here and press play when you're ready. Okay, so, we're continuing on from, just to replay it back. We first started this unit by learning how to approximate the area under a curve. We use Riemann sums, right? Or trapezoidal or midpoint. And then we segued into finding the exact area under the curve. And for today, it's, well, how do we find the area between two curves? Okay. Now, it's not just a matter of like introducing new conditions. You guys will soon see why it's beneficial to finding the area between two curves. You'll see the application behind it. But first, we got to work on the motor skills, right? So, two things that you want to take care of today. You want to be able to find the area between two curves analytically, also known as algebraically. And once we get the hang of it, we want to make sure that we can quickly do that on a graphing calculator because, very soon in the near future, all of this is going to be done with technology, and you want to be able to quickly set it up so that this technology can take care of it for you, right? So then we can get to work on all the applications instead. So just keep that in mind. Have your graphing calculator accessible. We will be using it heavily in the next, I want to say 4 lessons, okay? All right, here we go. So these next few slides you do not have to write down because you guys have seen these slides before, okay? Way back at the beginning of the unit, I asked you guys to find the area of under the parabola from 0 to 1. So then we learned how to approximate by drawing rectangles. Specifically here we had right Riemann sums, okay, which is definitely an over approximation for this case. And then we learned that we could actually use left Riemann sums, which in this case gave us an under approximation. And then we thought, well, you know what? What if we squeeze in more rectangles, right? And more rectangles. And then we learned, well, you know what? If we squeeze in more rectangles, we start to close in on the actual area, the exact area under the curve. So this table here, just so that you guys understand it, again, you don't have to write this down. N represents the number of rectangles. And notice, what did I just do? Abort. Okay. Notice how when I increase the number of rectangles all the way to 1,000, the left Riemann sum eventually plateaus at about 0.333. And notice how that's the same thing for the right Riemann sum. So somewhere in between these two values is the exact area. All right, that's about 0.333 if you take a look at those two values, right? And in the math world, that's known as 1/3. Okay, so we weren't able to get the exact area, but we were able to close in on it. Theoretically, we can go all the way to an infinite amount of rectangles, and this is where limits came in, right? You guys had that summation. That sigma symbol where you guys have the limit as n goes to infinity. I won't write out the whole thing. But that's where the calculus kicks in. What if we theoretically squeeze in an infinite amount of rectangles where they're super skinny, right? They have a width of something really close to 0. Then we can get access to the true area under that curve. So we learned in calculus that the integration does that, right? Or the antiderivative. We could take the integral of x squared dx from 0 to 1 to find the true area under the curve. And then here, using the fundamental theorem of calculus, part 1, we learn to integrate. And then we learn to evaluate by plugging in upper minus the lower. That comes out to 1/3, which is exactly what we predicted, or I predicted earlier. right? So we went from approximating to actually finding the area under a curve. Okay? So our next task here is, how do you find the area between two curves? Okay? Again, we'll talk about the applications later, but how would we find the area of just this pink shaded region here? Pause for a minute and really think about that. How would you logically find the area of that pink shaded region? Okay? Given functions f and g here. Press play when you're ready. Now, if you figured it out, great. Don't worry if you didn't, but it's actually very logical. Because if you think about it, if I just find the area under the curve of f, that would be all of this all the way down to the x-axis. Okay? And if I find the area under the curve of g, that's pretty much this. So naturally, what should I do so that I only get that pink shaded region? I would just subtract it. And here's a good illustration, a visual for it. To find the area between two curves, all you have to do is find the area of the top curve minus the area of the bottom curve. All right? So make sure you guys understand the logic behind it. Here's another visual. To find the region of S, that would just be the integral from A to B of top minus bottom. I'm going to say top minus bottom here. Now, I don't want to write F minus G because I don't want you guys to assume that F is always on the top and G is always on the bottom here, okay? So whatever that top function is minus whatever that bottom function is, okay? So that's really the key idea here. Okay, so here we go. This is the formal definition of it. Don't worry about it too much. Okay, here's example 1. Go ahead and write it down and press play when you're ready. Okay, so 2 things that you guys are battling here, okay? You have to know when this is a calculator problem and when this is not a calculator problem, okay? And it can pop up in either section of your AP exam. And again, I understand the exams may be different this year, but we want to be prepared for both, okay? So an easy indicator to know if this is a calculator or non-calculator problem is by looking at the 2 functions. Okay, here we have y equals x squared plus 1 and y equals x. Okay, now if you take a look at those 2 functions, you got to ask yourself, can I sketch these by hand? Okay, now these functions are simple enough to graph by hand. Now if you don't remember how to do it, that's okay, just refresh your memory, okay? So seeing as how these equations or these functions are simple enough, I would assume that this is a non-calculator problem. But I'll still show you how to do it with a calculator afterwards, okay? So here we go. We have an x and y axis. Okay? I know that this is a parabola that shifts up 1 unit. So I'm going to go ahead and call this 1 unit. And this is definitely not to scale. So here's a parabola that shifts up 1 unit. That's kind of like your k parameter, if you guys remember h and k. Y equals x is really just a linear function with a slope of 1 and a y-intercept of 0. So it looks a little bit like that. Okay. Now here, it says that it's bounded on the sides by x equals 0 and x equals 1. Remember, x equals a number is a vertical line. Y equals a number is a horizontal line, okay? So x equals 0 is really the y-axis, okay? and x equals 1, I'll just go ahead and draw it here. Okay, so we're finding the area of the region bounded above by y equals x squared plus 1, bounded below by y equals x, and bounded on the sides. So they're telling you what the boundaries are, okay? So if you take a look here, I'll color it in carefully. So if the parabola is the boundary above, then everything below it is the shaded region. And if the linear function is bounded below, then everything above it is what we're looking for here. So this shaded region is what you guys are looking for. Okay, how do I find the area of that? Notice how that is not a rigid shape that you guys are used to in geometry, right? And that's where the calculus kicks in. Anytime you're dealing with curves, you have calculus involved, okay? Okay, so here we go. Here's what you do. We want to find the area. So we know that we're dealing with an integral here. Okay? The region starts at what x value to what x value, right? So we're starting, let me color this in again. We're starting at the value of 0, and it accumulates all the way to x equals 1. So really, the indicators here are started and stopped by that green dotted line. So I know that I'm going to go from 0 to 1. Those are my bounds. Okay? Now here, we want to include our, I'll write it up here and I'll erase it later, top function minus bottom function dx. So I'll just put a little dx here. All right? So here we go. The top function, you can think of it like this. Let me go ahead and erase this so that you're not too much. There we go. Okay. Think of it this way. If you were standing in that region, boop, that pink dot, if you're standing at that pink dot and you were to walk upwards, what function would you hit? We would hit that parabola. So that is your top function. And if you were to walk down and you hit that function, that is your bottom function. So this is very easy to see if you have a visual, right? So I know that my top function is going to be x squared plus 1 minus the bottom function, which is x. Okay? So here is the easy part. We just have to integrate, okay? Now, these parentheses, since there's nothing in front of it and there's not multiple terms, we could actually make it easier and write it like that, okay? Now, when you guys have multiple terms, you do have to consider the parentheses, all right? So here, all we have to do is integrate. The integral of x squared plus 1 minus x is just x cubed over 3 plus 1x minus x squared over 2. We're using the fundamental theorem of calculus here, okay? After we plug it in, after we integrate, we have to plug it in. Upper always goes first, lower. I encourage you guys to do this because a lot of people forget their brackets or parentheses, okay? So we plug in our upper first, so that's going to be 1 cubed over 3 plus 1 minus 1 squared over 2 minus 0 cubed over 3 plus 0 minus 0 squared over 2. Okay? This comes out to, 1/3 plus 1 minus 1/2 minus, I think all of here comes out to 0, coincidentally, not always, okay? So if you do the math there, it should come out to, what is that? 2/6 plus 6/6 minus 3/6. That's 5/6. Okay? So the most important part is the setup. Okay? Second most important part, probably the integration. All right? So as long as you know what your top function is and your bottom function is, you're good to go. Okay, so using a calculator, all right? Here we go. And I'm going to go through this quickly, so you might have to replay. I just want to make sure that the video doesn't take too much space here, okay? All right, first thing you want to do is reset it. So you want to reset second plus 712. That way everyone is on the same page. We're all in radian mode, okay? All right, here's what we're going to do. We're going to go to our y equals, okay? Just like how we approach the problem, we graph it first, all right? I don't have the screen in front of me, but go ahead and make y1 x squared plus 1, and go ahead and make y2 x, okay? Obviously, when you hit graph, you can see the picture, okay? But here's what you're going to do. You're going to go to second and quit so that you can go to the home screen, okay? So here's what you're going to do with a calculator, just to show you how it's set up. We're going to try to type out the integral from 0 to 1 of x squared plus 1 minus x dx, right? But you guys want to remember how to take your shortcuts here. So here's what we do. We're going to take the integral, so that's math 9. Math 9 will get you the integral symbol. So right now you have this. You want your lower and your upper bound to be 0 and 1 respectively. Now instead of x squared plus 1, we can input y1. Okay? So just to refresh, y1, to get to those y1 or y2 functions, you go alpha trace. When you go to alpha trace, you could pick y1. Okay, then you type minus, and then you go alpha trace again for y2. And then D, and then you just input the x there, okay? Once you crank it out, it should come out to whatever 5 over 6 is. What is 5 over 6? It'll come out to 0.833333333, right? Which is 5 over 6. All right? There you have it. Okay? So recall how to get to the integral symbol, which is math 9. And recall how to copy paste functions, which is alpha trace. Okay? All right, here we go. So here's example 2. Go ahead and write it down. Press play when you're ready. Okay, so here I would argue that you can graph this by hand, but we're gonna use it. We're gonna use a calculator here. Okay, so here's what we do. We have y equals x squared, and then we have y equals 2x minus x squared. Go ahead and call this y1 and y2. So type that into your calculator now. And I'm going to go ahead and actually do it with you. So x squared. Now, at any moment when you're using your calculator and it's not matching up with mine, you definitely want to check in with me so we can troubleshoot, okay? Okay, so we type in our y1 or y2. We click on graph, which is the upper right button. And it looks a little bit like this on my end before I want to zoom in. So if I had to just roughly sketch this, I got something that looks like this. And then I have something that looks like that. Okay? You guys could go ahead and click on zoom, which is that top middle button. We could go to zoom in, press enter, and that should be enough to get a better view. That's just optional, okay? But you'll notice that there's a little region that's enclosed. That green area right there, okay? So some things that you want to note, okay? Can you tell which function is the top and the bottom? Press play when you're ready, okay? So here we go. The integral, now if we're taking a look at colors, if we're in that green region, that top function is the red one. And the red one is the 2x minus x squared here. So in this case, I would have y2 here minus the bottom function is that blue parabola, which is y1. I should change this to red so that I don't confuse you guys. All right. Okay. All of this is with respect to x. But do they tell us from where to where? Okay. So if I take a look at the picture, it looks like it's going from 0 to 1. But here's the thing about this segment, okay? You cannot assume because it could be a decimal value. It looks like it's from 0 to 1, but we're not really sure, right? So here's what we do. There's a new function that you want to learn, okay? So remember how you guys were calculating zeros, right? So let me go back to this calculator. When we were calculating zeros, do you guys recall how we were able to access that? How do you calculate a zero? Okay. Press play when you're ready. So to calculate a zero, you would go to second and trace because it says calculate right there, okay? So go ahead and do that. Second trace. Once you go to second trace, they give you a menu of options, right? Now, instead of finding a zero, what we're going to do, I'm just going to go back to the graph real quick. We need to find out where that region starts and stops. That region starts and stops right where they intersect. Okay? So the calculator is really cool because they can help you find out where they intersect. So here's what you do. You go to second, you go to trace, and if you guys take a look at the number 5 says intersect, okay? Two things that you guys got to know about calculating. You got to know how to find your zeros, and you got to know how to find your intersections. Those are used a lot of the time on the exam, okay? So second trace 2 or second trace 5. In this case, we want to find the intersection. So I'm going to go ahead and press 5. Okay? Now, a few things are going to happen, okay? And I'll write it down for you. Don't press anything yet. They're going to ask you 3 questions. First curve, second curve, and to guess. Okay, so if you only have 2 functions in your y equals, the first 2 questions do not matter, okay? Because if you only have 2 functions and they ask you for the first curve and the second curve, it's automatically all of those functions, okay? But if you had like 3 or 4 different functions, you might have to pick and choose, okay? So here you could just press enter and then enter again. At this point, they ask you to guess. So here's the issue. There are 2 intersection points, okay? You actually have to guess the one that you want, okay? So for instance, if I think that this one is about 0, I'm going to type in 0 here. If I think that this is about 1, I'm going to type in 1. Because if you don't guess, they might give you the same intersection twice, okay? So I'm going to go ahead and press 0. And then press enter. And then at the bottom of your screen, it should say intersection. That's how you know if you did it right. Okay? And it did confirm that the lower bound is 0. Okay, so I want you guys to go ahead and do that again and find your next intersection. So in this case, we would do second, trace, 5, enter, and we're going to guess 1 now. Okay, so I'll do that with you. Second, trace, 5, enter, and for guess, I'll put 1. And it turns out that it's actually 1. Okay, now if you're not getting that, please do let me know. All right, so sometimes you have to find the bounds yourself. Okay, so here you go. We have our setup. This is what we call our setup. All we need to do is figure out our answer, okay? So we're going to let the calculator do all the hard work. So we're going to go to our home screen. So we'll go to second mode. And then we'll set up our integral symbol, okay? Now go ahead and do that. Pause right now. But if you need a reminder on what buttons to press, continue this video, okay? So to type this out, we need the integral symbol. So we need to press Math 9 for integral. Okay, we're going to go from 0 to 1. So we'll fill in the bounds. And then y2 is going to go first. So we have to go to alpha trace y2 minus alpha trace y1. And then that toggle over to that D and then put in an X. Enter. You should get 0.33333, right? Also known as 1/3. If you're going to write it in a decimal, make sure that you round it to 3 decimal places always, okay? So there you go. You guys are learning something a little bit new regarding the calculator. You know, it's always going to be a little bit weird at first, but you guys will definitely get the hang of it. I haven't had anyone have trouble or issues with the calculator once practice starts, okay? So just keep that in mind. Okay, so here's your next one. Part C, okay? So I asked you guys here, is this a calculator or non-calculator problem? Okay. Would Mr. Lee expect you to sketch these 2 red functions by hand? Yes. No, absolutely not. These are not common functions. So this pretty much implies that you guys will be using a calculator, okay? Now, most of the time I've seen that people can set up the integral. It's just a calculator error where somewhere there's a syntax error, okay? So please do reach out if you are not getting the same values, okay? First step to finding the area, we need to know how the picture looks like. The point of the picture is so that we can see what's the top and the bottom, but also it helps us find what the intersections are, right? So go ahead and type out, I'll try to be consistent with the colors here, especially if you're using a colored calculator. We're going to go ahead and let y1 be x divided by the square root of x squared plus 1. And we're going to let y2 be x to the 4th minus x. Okay? Some things that I've seen happen. Make sure that when you square root x squared, you toggle down so that plus 1 is not up in the exponent, okay? Okay, the next thing is make sure that when you type out x to the 4th, you step back down for a minus sign and then x. Don't put the minus x in the exponent. Other than that, I don't see where else you would have an error, but, you know, you never know. Okay, so go ahead and do that. I'm going to graph it myself. So x divided by square root of x squared plus 1. y2 will be x to the 4th Now remember, to do exponents, you use that little caret button, okay, right above the division sign. Okay, so if you guys remember, before we hit graph, in the last example, if you followed it with me, we zoomed in on the problem. So we changed the size of the window here. So what you guys want to do in practice is to go back to your default window, you guys want to press zoom 6. When you guys press zoom 6, it goes back to -10 and 10 on both ends. Okay? Because I always see students get confused because another student has a different picture from the other one, but they don't realize that it's just zoomed in versus the other one is not. Okay? So from the get-go, I mean, I'm just sketching it roughly here. Your blue function looks like this, and your red function looks like a parabola that got punched on the side, something like that. Okay, but we could definitely zoom in. So I'll press zoom 2, and you can actually move that cursor where you want it to zoom in. I'll try to get into the center of that region. And that looks pretty good, this picture that I drew, okay? It doesn't have to be super accurate, but there's your enclosed region, right? So what does that tell you? Think about what information you already know as of now, okay? Press play when you're ready. So right now, we know what our top and bottom function is, okay? Clearly, if you're in that green region and you walk all the way up, you're going to hit that blue function, which is y1. So this is going to be y1 minus the bottom function y2. Okay? So the purpose of the graph, it gives you two things. It tells you what the top and bottom functions are, but it also tells you what the intersections are. So I'll locate this in purple. So if I'm just looking at it, it's looking like 0 and 1-ish, but I have to be sure. Okay? So go ahead and find your two intersection points. Pause there. If you need a refresher on how to find the intersections, continue this video, okay? Okay, so remember, to find the intersection, you're going to go to second, trace, and then you're going to press the number 5 for intersection, okay? They ask you 3 questions again. It's first curve, second curve, and to guess. Since we only have 2 equations, we're going to press enter, enter, and to guess, I'm going to assume that this is 0. So I'll type in 0, enter, and it's confirmed that the lower bound is 0. I'm going to do it one more time. Second, trace, 5 for intersection, first curve, enter, second curve, enter, guess. That's looking like it's 1 point something. I'll just put 1.1. You don't have to be exact, okay? So if you take a look here, the intersection, if I could just kind of model it for you, on your screen it should say intersection, and right below it is x equals 1.1807757. Okay? That is this value right here, 1.18, yada, yada, yada. Okay. This is where the region starts and stops. So here's the thing. We cannot round this answer because it's not the final answer. And if we round too early, we're going to screw up the final answer. So we have to type in 1.1807757 here. All right. Or if only there was like a copy paste function, right? So this next part here is optional, but a lot of the students use it. Okay. So let's say you found an intersection and it was this really lengthy decimal, right? Okay. So on your screen, you should be seeing this right now, okay? What you would do next, and I'll show you using a calculator, you would go to, let me erase this. you would go to second and mode to go to your home screen. Okay? Second, then mode. And right above the on button is this STO button. That stands for store. Okay? You're storing that previous value. Okay? So when you press that, I'll do that with you. On your screen, it should say ANS arrow. So what we're saying is we're turning our answer into something. Okay? And if you take a look at all this entire calculator, all of the green stuff are letters, right? And then we have a green button. So what we do is we're going to press alpha, and then we're going to designate some letter, okay? You could use any letter you want, but I like to just start it off as A, okay? So I would do alpha, then that math button for A, and then it should say that on your screen. Once you press enter, the calculator is smart enough to remember that every time you press A, it will represent the 1.180 whatever, ever, okay? So you guys have two options here. Now that when you guys type it out, and I encourage you guys to do it both ways, we can just type this out the way that we see it, or what is a little bit more efficient is we would go to math 9 for the integral. We're going to go from 0, and then here I will go to alpha, then A, because now the calculator knows that A represents 1.1807757, okay? If you don't like remembering that button, you can just write this all day long, but do not round it, okay? How do we get to y1? That's alpha trace 1 minus alpha trace 2 dx. Go ahead and plug and chug there while I work on this. Okay, so math 9, 0 to A. Alpha trace y1 goes first in this problem, minus alpha trace y2. What did I forget? Oh, dx. Okay, so if you did this right, you should get 0.785 rounded. Okay, if you didn't get that, please do let me know, okay? So again, it's setup and answer. You just got to know how to efficiently use that calculator, all right? Okay. We're running out of time here. Okay, let's do this last one. Let's call this part G, only because I don't remember what letter we're on, okay? Okay, so find the area of the region between the graphs of F and G, okay? Taking a look at how these problems are set up, believe it or not, they wouldn't expect you to graph this by hand, okay? Although you could, but they tend to focus more on the calculus and not the algebra behind it, okay? So go ahead and try this on your own. This one's a little bit different. And then press play when you'd like to hear more, okay? Or if you're done. Okay, so here I'm going to just go ahead and designate y1 to be 3x cubed minus x squared minus 10x. And y2 to be negative x squared plus 2x. Just so that we're all on the same page, okay? So I'm going to go ahead and type it in. So y1 is 3x to the third. Make sure you jump down. Minus x squared minus 10x. Okay, for y2. Okay. anytime a function starts off with a negative, you want to use the negative symbol, which is right below the 3, right next to the enter button, okay? Don't use a minus, otherwise you're going to get like a prompt that says syntax error, okay? So make sure you use negative x squared plus 2x. Okay, other than that, I don't see anything that can go wrong. So these here, you want to use the minus sign. I know, calculator is so bright, but in some of these aspects, it's kind of dumb. Minus signs are used, but when it's in the front, you use a negative symbol. Okay, after so many years, I don't know why they didn't fix that. Anyways, okay, here we go. So I'm going to go to Zoom 6 just so we can get back to the default window. Okay, and if I had to quickly sketch this, it's looking like this, and Y2 looks like, I'm probably going to butcher this. Looks like that. Okay, find the area of the region between the graphs, okay? But if you notice, there's actually 2 regions. We have this region, but then we also have this region. They're both enclosed, right? So how do you guys suppose we would do this? Okay, so here, if I'm in the yellow region, I know that my top function is that blue one. So in this case, my blue one, let me go back and check my colors. My blue one is Y1, and my red one is Y2, just to make sure that we're on the same page. Okay, now those of you that are using black and white calculators, it really doesn't matter. You just got to follow what's being traced first, okay? Okay, so I know that from somewhere to somewhere, that yellow region is basically Y1 minus Y2. And again, that's the yellow region. So if I want to find the area of that green region, it only makes sense to just add the green region, right? So that means that I would have to actually set up another integral. But when you guys are in the green region, the top function is the red one, which in this case is y2 minus y1 dx. Okay? So what are we missing? We're missing bounds, okay? So the bounds are where they intersect, all right? So it's going to take some time for you guys to figure out, but pause this video here or follow along with me. I'm going to go ahead and find it. So I'm going to go to second, trace, 5, enter, and I'm going to go from left to right. I want to guess that my first intersection is -2. So I'll type -2, enter, and it turns out that this is -2. So that's going to be my lower bound for my first one. I'm going to do it again. Second, trace, 5, enter. I think my middle intersection here, it looks like it's 0-ish. And it turns out to be 0. Okay? So that means the green region would start at 0 as well. And the green region will end at the next intersection. So second, trace, 5, enter, that looks like 2. And it's confirmed that this is also 2. And it turns out to come out clean. But I encourage you guys to practice it because it doesn't always do that. All right? So here, you would have to type it out carefully. Okay? So go ahead and do that. Math 9 gives you the integral. -2, 0. Make sure you use a negative symbol, okay? Alpha trace y1 minus alpha trace y2 dx. Plus, you go to math 9 again. From 0 to 9. Alpha trace y2 minus alpha trace y1 dx enter. I should have done that, but let me go ahead and type it out. Math 9 negative 2 to 0 alpha trace y1 minus alpha trace y2 dx plus math 9 from 0 to 2. Now it's alpha trace y2 minus alpha trace y1 dx. Okay, I got a clean number. It's 24. Okay, and that's it. So sometimes you have multiple regions. If they're nice enough, they'll give you the bounds. If not, you're going to have to find the intersections, okay? What else is there? Do I have one more? We'll end it with this, okay? Here is part of a free response question, okay? Go ahead and try it, all right? We have, oh, this is a calculator problem, so calculator active, okay? We have these two functions f and g. Find the sum of the areas of regions R and S. Just like what we did before, right? R and S. Okay, so try it out on your own. And then press play when you're ready or if you need help. Okay, here, the issue here is that if you're looking at the picture that they provided, they don't tell you what function is which. So you actually have to use your calculator, type these two guys in, and actually figure out which one is which. Okay? So go ahead and do that. While I look up the decimal so that I don't have to calculate it. Okay. So some things to troubleshoot. If you're not getting the picture, it could be that you didn't put the minus 2x up in the exponent right there. So it's e to the x squared minus 2x altogether. Everything else should be, there shouldn't be any other syntax errors. So once you type that out, it turns out that this, I'll color it. This, why did I use the same color? This function right there is g of x, okay? And the other function, this one right here, that's f of x. Okay, so in our calculator, this is really your y2 and this is really your y1. Okay, assuming that you guys wrote it in order. So here's the setup. Okay, we know that we have to have two different integrals. All right, we know that it's with respect to x. We know that if we're in the region R, the top function is y2, so this will be y2 minus y1. But if you're in region S, the top function is f, which is y1 minus y2. The only thing we're missing here are bounds. Okay? So to find the intersections, you would have to, second trace 5 3 different times. Okay? Or actually one time. Because here, they actually give you the intersection. It's 0 and 2. So I know I start at 0 and I end all the way at 2. We just need to find out what this guy is. Okay, so go ahead and find it. It should be 1.0328332-ish. Okay, so you could either decide to type that or let A equal that. Once you type it out, you should get 2.004. That is your goal, okay? If you're not getting that, please do let me know. Again, do not round until you get to the final answer there, okay? That's pretty much it. All right, it does get a little bit more technical later, but we'll get to that when we get to that. All right.